This is Note Taking Guide 2.9. Today we're going to teach you how to solve systems of equations by substitution. So what we're going to do here is we're just going to use one equation to substitute into the second equation. I think that it's going to be easier than you think it is. It looks like it's going to be a lot of work, but it's really just solving an equation. So let me show you what I'm talking about here. In this top equation it says y equals 4x. Well, can I take 4x and substitute it into the other equation in place of the y then? If y equals 4x, I can actually rewrite that as 3x plus, and instead of y, I'm going to put 4x because I can substitute that into the equation and then equal it to 21. I can solve that equation now by combining these like terms and getting 7x equals 21. Divide both sides by 7, and I get x equals 3. Now I'm not done right here because if you notice up here in our equations, I actually have y's and x's. So in order to have my solution, I have to have an x and I have to have a y as an ordered pair. Right now I only have my x, so now I need to substitute back in and also get my y. So I'm going to go back into what I think is the easiest equation to look at, which is this top one up here, by far the easiest one. So I'm going to rewrite it down here as y equals 4x, and I know what x is. X is going to be 3, so 4 times 3 is what I'm going to write in here. 4 times 3 is actually 12, so my y value is 12. So up here where I said your answer is an ordered pair solution, x comma y, my answer is actually going to be my x value, which is 3 that I solved for, my y value, which is 12 that I solved for, and my solution is that ordered pair. So that's what we're going to be doing today. We're substituting a value into the other equation. So here on this one, if you'll notice, we have x is equal to 6 minus y. What we're going to do is we're going to substitute that into the second equation in place of the x. So instead of writing x plus 3y, I'm going to write 6 minus y plus 3y equals 18. I'm going to combine like terms on the same side and then finish solving my equation. So I have a negative y, or a negative 1y plus 3. So a negative 1y plus 3 is actually 2y. And if I combine those together and rewrite it, then I can really just finish solving this equation. To isolate that variable, I want to subtract that 6 to the other side. So I get 2y equals 12. Divide both sides by 2. And I get y equals 6. Okay, if you remember though, we said our answers have to be an x comma y, so I'm only halfway there. I have my y equals 6. So I'm going to pick what I think is the least ugly of the top two equations, and I'm going to substitute back into it. So x equals 6 minus y. I have my y value, x equals 6. My y value is 6. So x is actually going to be 0 because 6 minus 6 is 0. So my ordered pair solution is x, which is 0, and y, which is 6. Again, if you wanted to know whether or not those were correct or if you made an error, you can substitute these back into both of these original two equations. If it satisfies both of them, then you did it correctly. If it doesn't satisfy both of them, then you did something wrong in your work. All right, next example. Again here, you guys, this is set up for substitution. It says x equals that junk, 2y minus 1. So I'm going to substitute that into the other equation in place of the x. This one gets a little more complicated, but we've been solving equations like this, so we're going to be all right. We're going to go 2 times, and then instead of x, I'm going to put 2y minus 1. Then I still have the plus 4y, and it's equal to 46. So I'm going to first solve this by distributing this 2 through to both parts of my parentheses. So 2 times 2y is 4y. 2 times a negative 1 is a negative 2. I then have plus 4y equals 46. I'm going to combine my like terms here. The 4y plus the 4y is 8y. So I have 8y minus 2 equals 46. And I'm just going to continue to solve this. I'm going to add that 2 to the other side. So I get 8y equals 48. Divide both sides by 8. And y equals 6. Again, though, we're looking for an x comma y solution. I only have my y, so I have to go back up and substitute into one of the two equations. I think this one looks like the easier one to sub into, so I'm just going to rewrite that equation and substitute my y value into it. So x equals 2 times 6 minus 1. 2 times 6 is 12. 12 minus 1 is 11. So x equals 11. So my ordered pair answer is x comma y, so 11 and 6. All right, there's a couple of checkpoint problems there on your worksheet. I want you to take a minute and do those. You can come up and check them with me and if you're in class, and if you're not, just check them with me later. But let's make sure that you get those checkpoint problems done. Then flip over to the back of your note-taking guide. There's a few more problems to go over. There are some special cases that can happen when we're solving systems of equations, so we want to go over those. But first I want to work a problem for you like this one, like the letter D. Do you notice how all of the other ones have been solved for a variable? And if you look at these ones this time, this one's not solved for x or y. This one's not solved for x or y. So we really don't have it set up for substitution yet. So in order to substitute, I would have to decide whether or not I could get one of these set up for substitution. This top one right here looks fairly simple as far as setting it up for substitution, because we can actually get this y right here by itself pretty simply. So I'm going to write this equation down again really fast just so that I can manipulate it to be in the form I need it to be. So I want that y by itself, so I'm going to subtract that 2x to the other side. When you subtract it over there, remember that they don't combine together. One has an x on them and one doesn't. So you're actually just rewriting it so that we can use it. So we have y equals a negative 2x minus 6. Now that I have that, I could substitute it into the other equation in place of the y. So I'm going to take this junk right here, and I'm going to substitute it into the second equation in place of the y. So I'm going to go 3 times x plus 8 times negative 2x minus 6 equals 4. And I'm going to solve that equation. So the first thing I have to do is distribute this 8 through. So 8 times negative 2 is a negative 16x. 8 times a negative 6 is a negative 48. And that equals to 4. Those x's combine together to be a negative 13 minus 48 equals 4. I'm going to add the 48 to the other side, and I get 52. So negative 13x equals 52. I then need to divide by a negative 13, and when I do that, I get negative 4. So x equals negative 4. Now, I'm not actually done yet because I still need that x comma y, which is kind of, annoying. It seems like I've done plenty work in order to get that. So I know that up there my x is going to be a negative 4. I actually need more work though, or no more space to work, so I'm going to erase this. And then I'm going to go and substitute back in to find my other solution. So I'm now going to take my negative 4, which is my x value, and substitute it back in to one of the two equations. So instead of 2 times x, I'm going to have 2 times negative 4 plus y equals negative 6. So that's negative 8 plus y equals negative 6. I'm going to add the 8 to the other side, and I get y equals 2. So my ordered pair solution is going to be negative 4, positive 2. Okay, so that one is a little bit longer because it wasn't set up for substitution, but even if it's not set up for substitution, you can still set it up for substitution by solving for one of the variables in one of the equations, okay? All right, so on this same page, we have this little special cases box, which just reminds us that sometimes we don't always have an ordered pair solution. Sometimes when we have infinite solutions, our variables are going to cancel out and we're going to get something that looks like 4 equals 4, or 8 equals 8, or negative 21 equals negative 21. We're going to get a true solution. anytime you get a true statement, you have infinite solutions. So the opposite then would be what happens when you have no solutions. You're going to get a false statement like 7 equals 4 or 21 equals negative 36. Something where the variables cancel and it's false. So you can have no solution, many solutions. If you remember, no solutions was when we had parallel lines when we were graphing them. Infinite solutions was when we would graph something and then we would have the exact same line right on top of it. So the same thing can happen when we're solving algebraically. We just need to be aware of what happens with the algebra. So let's take a look at these next two examples and solve them and see what happens. So this one says x equals this junk. So we're going to substitute that junk in place of the x. So instead of writing x, I'm going to write 3 minus 2y. I'm then going to add the 2y and equal it to 8. Well, right off the bat right here, you can see the problem. Those y's are going to cancel. So I'm going to get 3 equals 8, which is a false statement. That's not going to be true. So it's false, which means we have no solution. Now, you can also use that mathematical symbol, no solution, that looks like this, in order to save some time writing that out. Okay, last example here, set up for substitution. We're going to take this x plus 5. We're going to substitute it in over here in place of y, and we're going to solve. So we have 3 times x plus 15 equals 3 times, and instead of y, we're putting in x plus 5. So I'm going to rewrite over here 3x plus 15, and then here I get 3x plus 15. Now, we're going to solve this. We're going to get our variables by itself. If you notice, though, right now, this is already exactly the same. This side equals that side. When that happens, things are going to cancel. But let's pretend like we didn't notice that, and let's just keep going. So say I want to move these 3x's over here to be with these 3x's. So they cancel here, and they cancel here. And I end up with 15 equals 15, which is a true statement, which means I have infinitely many solutions. And if you remember, you can use that all real number symbol if you want to on that. Okay, that's how we substitute, you guys. So remember, finish those 2 checkpoint problems on your note-taking guide yourself. Check them with me to make sure they're okay. And then get started on your homework. Thanks, guys.